Hello, welcome back everyone to this channel. And today we're having a special equation and it says if 3 raised to the power n minus 2 raised to the power n is equal to 65. We're therefore asked to find m. And like I already said, the first thing you must do is to say solution. Solution. We're going to say 3m minus 2m equals 65. Yes. As you see equation like this, you must think of how, what am I going to bring in mathematically to be able to solve for the end that we have been asked to solve for. So I will think of, since I have a negative sign here, I cannot bring a concept of the difference of 2 squared. I want to bring in the concept of the difference of 2 squared. There are many methods with which you can solve this anyway. You can take the log of both sides and go about looking for m, and you get the right answer. And whatever method you employ or you apply, it must satisfy this equation by checking it. Whatever value you have, you put it in the place of the n. If you get 65 back, you are correct. So I want to go by the method of difference of 2 squared. If I have m, I cannot bring a square on both sides. I want to say let's raise both sides to power m. That is to say, I have to write 3m raised to power n raised to power 1 minus 2m raised to power 1 equals to, of course, it's raised to power 1. You see this? But I can say 1 is equals to 2 over 2. Therefore, if 2 cancel 2, it's definitely going to be 1. So if I replace the 1 by 2 over 2, like I said, I'm introducing the concept of the difference of 2 squared. That's why I'm doing this. 3 raised to power m raised to power 2 over 2 minus 2 raised to power m raised to power 2 over 2 equals to 65. Allow 65 to be so. Okay now, so, but I can also rewrite this to be 3 raised to power m 1 over 2 times 2. This is correct. Minus 2 raised to power n times 1 over 2 times 2 equal to 65. This is also very correct. But remember, if we have from the laws of indices a raised to power m raised to power n, it can be equal to a raised to power m times n. So you multiply the power. So I'm going to multiply the m and the half and leaving the square so that we can have the power, the square, and go about the difference of 2 squared that we eventually want to turn our equation to. Alright, so from there we can say 3 raised to power m over 2 minus 2 raised to power m over 2. Of course, this is raised to power 2. We're forgetting that. Equal to 65. You see this? Yeah. Now we have a square. This is a typical example of the difference of 2 squared. Mathematically, we are imputing what can enable us to achieve our goal of finding m. You see, that's why we brought in this concept. And if you have another method as you go through this, you can show us in the comment section. Okay, so we continue. And if I have a raised to power 2 minus b raised to power 2 is equals to a minus b times a plus b. You see this? Is what we have here. And let's go by saying that let a equal to 3m over 2 and b equal to 2m all over 2. That is to say, from here, I can say a squared minus b squared equal to 65. Yeah? And what is a squared minus b squared? Difference of 2. I want to bring this in. That is to say, a minus b times A plus B equal to 65. And if we agree on this, we can say we want to rewrite 65 in a multiple form. I can decide to say 65 should be rewritten as 1 times 65. This is correct. Or 65 times 1. I'll put it here. It's correct. But when you do this, I've done it before. If I want to go with this length, we will have an extraneous answer that will not satisfy this equation. Whatever answer you get from here, when you put it here, in place of n, you will not get 65 as an answer. You see that? So this, whatever you get from here, is extraneous. Alright, so I want to say if out of 65, I want to divide it by 5. 6 divided by 5, I have 1. That's 5 here, remaining 1 to be 15, I have 3. Okay, so if I say 5 times 13, the same thing as 65. You see this? So in place of 65, I want to write 5 times 13, like I have this. Okay, so what am I saying? I'm saying that A minus B into A plus B is equal to 5 times 13. You see that? It's becoming more beautiful. But there is something here I must show you at this point. If A minus B times A plus B equals to a positive number, I need to say A is definitely greater than B. If that is correct, that means A plus B is greater than A minus B. Assuming, since we agree, let's assume A is 4 and B is 2. If A is 4, it's definitely greater than 2, and B is 2, for example. 4 minus 2 will be 2, but here 4 plus 2 will be 6. And this means that this time we take this bigger one, that's why I'm doing this explanation, and this other one we take the smaller part of the 65, which is in this case the 5. So what am I saying? What I mean here is A minus B will be equal to 5, equation 1. And A plus B will be equal to 13, equation 2. So here from there we have 2 simultaneous equations that is also solvable and becoming simpler with us also. So what do? We're going to eliminate one of the terms. Let's say B. So if we eliminate B, so we're adding. It becomes 2A equals to 13 plus, that is 18. You see this? So A will be 2A over 2 equal to 18 over 2. This A will cancel, 2 will cancel 2 to be left with A. And 2 into 2, 1, 2 into 18, that definitely is 9. And this is 9. So I've gotten A to be 9. So we're going to put A equal to 9 in equation 1. Put A equal to 1 in equation 1. If we put A equal to 9 in equation 1, we have 9 minus B equal to 5. Yeah. So minus B will be equal to 5 minus 9. Minus B will be equal to minus 4. Eventually B will be equal to 4. You see, we have got to B equals to 4. A equal to 9, B equals to 4, and A is equals to 9. But don't forget, we're not looking for A and B, we're looking for N. And previously we have said let A be A equals to 3 raised to power M over 2, and B equals to 2 raised to power M over 2. So in place of A, put 9. It will be 9 equals to 3 raised to power M all over 2. So we have A to be 9. Place of A, like we said, we put 9 will be equals to 3 raised to power M over 2. And we can write 9 to have the same base at this part, which is 3. So that this will say 3 raised to power 2, this is 9, which is equal to 3 raised to power m over 2. And we know from the law of EDD, if a is raised to power n is equal to a is raised to power m, it means that n is equal to m from the laws of indices. So we are going to equate the powers. That is to say, 2 will now be equal to m over 2. And if we multiply both sides by 2, n will be equal to 4. From here, m is equal to 4. And from the second part, b equals to 2 raised to power m over 2. And we know that b there is 4. So in the place of b, we are going to put 4. If I say 4 equals to 2m over 2, we are fine. But the 4 can be written having the base of 2 also. So 2 raised to power 2, that is 4, which is equal to 2 raised to power m all over 2. So the base are equal according to the law there. We can equate the power. So from there, m is also equal to 4. You see that? So 4, m is equal to 4 definitely from the substitution of a and b. So if we want to prove actually if what we got is correct, we want to come back to the original equation and put wherever we have m, put 4. Wherever we have m, we are going to impute 4 to check our equation if we are right or wrong. So what do I mean? So 3 raised to power m will be 3 raised to power 4 minus 2 raised to power m will be 2 raised to power 4 equal to 65. You see? And 3 raised to power m will be 3 times 3 in 4 places, which gives us 81. And 2 raised to power 4 will be 2 times 2 in 4 places, which will give us 16 equal to 65. You see, 65. And if we do this, we have 18 minus 16, 81, sorry, 81 minus 16, then you will have 5, and definitely 6. So this is 65 equal to 65. What does that mean? Meaning that the value of n that will have to be 4 satisfy the original equation. And the value finally, the n that we're asked to find is n equal to 4 as our final answer. Thank you for staying tuned. Do well to subscribe, like, and share. God bless you.